Dalton. I just want you to list two ideas about his theory. So in your book on page 104, they give you multiple. Somebody want to read some of those ideas for us? All right, go Jacob.
Matter is composed of extremely small particles called atoms are indivisible and indestructible. Atoms of a given element are identical in size, mass, and chemical properties. Atoms of a specific element are different from those of another element. Different atoms combine in simple whole number ratios to form compounds. In a chemical reaction, atoms are separated from that are combined or rearranged.
All right, so write down two of those that you didn't already know. Most of you probably already knew that Dalton understood the concept of an atom because he was building off of Democritus. So write down two that you didn't know. We talked about the law of definite proportions and the law of multiple proportions, and that relates to different atoms combined in simple whole number ratios to form compounds. That would be the law of multiple proportions. We just often go out and find new substances, and then from that we try to determine what if it's a compound or an element. And if it's a compound, it will be breaking down to where you have the mass associated with the whole number, like H2O. The law of multiple proportions states that you cannot have like H 1.50, it has to be whole number ratios. Is everybody clear on that? That's what makes science predictable. And if you have something that you shouldn't have, like, and the police officer pulls you over, that's how they know that it is what you're looking for. Now today we're going to continue on with our separations, the chromatography, and we have two unknowns up here. Now today we're going to use an ethanol alcohol to separate these substances. And the reason why we're going to do that concerns the polarity of substances. You have basically two ways to describe liquids, whether they're either polar or non-polar. What is oil? Is oil polar or non-polar? Oil is non-polar. Okay, that's the reason why oil and water don't mix. So if you're polar, you're going to mix with polar things. There's no saying, it's called like dissolves like. So alcohol is somewhat polar. Water dissolves in alcohol. Now the polarity can determine whether other substances mix with it very well. For example, food coloring tends to be very polar, so it's going to dissolve in water well. Other dyes might not be as polar, so they're not going to dissolve very well in polar things. So you have to find a substance that is less polar, and ethanol alcohol is less polar than water. And because of that, it will dissolve the substance and move it up and create the data that we want to see. Like we showed you yesterday, the ds is the direction or the distance from the line to the highest point the color traveled. Remember that? Do I need to redraw the graph from yesterday? Okay, most of you have it written down. Water is polar. That means it sticks to stuff. I'm sure you've heard that water is not wet. It is sticky because of its polar nature. Dylan, write this down. Write this down. And you've got the ethanol compared to the water.
This illustrates how small atoms are.
Alright, so atoms are really, really small. If you just took a sip of water, like just a little sip of water, it would take everybody counting on the earth, that is everybody counting 1,000 a second, 24 hours a day, 7 days a week, over 2,000 years just to count the water in a sip of water. It would take 2,000 years for everybody counting 1,000 a second. There's just a lot of atoms in a very small space. It's kind of almost mind-boggling just how small atoms are relative to us.
Pass electricity through a glass tube. Glass tubes from which most of the air has been removed. Such tubes are called cathode ray tubes.
Visual of a motor, electric motor. You have basically copper wire and you have a magnet that spins around it. Now, if the magnet goes in one direction, what type of motor is that? It's a direct current motor. So you're creating electrons that flow in a direct current. And Edison, and who worked to try to produce electricity and then distribute it the longest distance. So it's one thing to make electricity, it's another thing to like send it to your home, make it travel over a long distance. Now the direct current method this way doesn't travel very well. Edison was working on this way and he couldn't get, the wire would heat up. The more voltage he tried to put through, the wire heated up and he lost his electrons. So the direct current method doesn't work great for electron travel. So what they end up doing is reversing the flow of the magnet, or how it spins. It spins one way and spins the other. That's called the alternating current. The electrons are actually flowing back and forth through the wire. And when it does that, it creates more efficiency in how the electrons are transported.
So would it be that every single time you want to shift gears per se, it would be
Things organized. So different solvents have the ability to dissolve different things. Water is just really available to us, so we tend to do a lot of our cleaning in solvents, like water. However, when we look at our unknowns today, they don't dissolve very well in water because they're not very polar. So the unknowns we have today are not polar. They are slightly polar, but not very polar. Whereas what we looked at yesterday with the food coloring tends to be dissolved in water, so it is more polar, and that's why it separates easier. So the unknowns we're working today are not dissolved in purely water, so that makes them less polar. And you can see that up here with the ethanol. So ethanol has basically a 2-carbon structure. What does methanol have? It has a 1-carbon structure. This is ethyl alcohol, which a lot of people consume and get in trouble with. There was a UK student that just consumed some alcohol and ran over a little kid. So the alcohol is dangerous, and then it makes you sleepy. And if you're sleepy, you tend to do dumb things. So if you're already a little bit tired or lazy, I'd stay away from alcohol. So alcohol has these 2 carbons, and the hydrogens are going to be what's going to give you that positive charge. And you can see here that there's a pretty big distance between the negative and the positive here, whereas the distance is shorter here. So this is going to be more polar, the water will be, and this is going to be less polar. Now, how do we know they're both polar? Like dissolves like. You can take alcohol, ethanol, and dissolve it in water. So if they dissolve together, then they're polar. Does oil and water mix? They dissolve each other? No. Oil is what? Oil is non-polar. Water is polar. So you have to add soap typically to get the oil stains out of your clothing. And soap helps break down the oil to where the water can then wash it away. So oil is non-polar, write that down. Oil is non-polar, and water is polar. And then there's a lot of different solvents that are in between there as far as how polar you are, how non-polar you are. So today you're going to work with the alcohol, which is slightly less polar, to do your separation. Now you can see right here that it's not working as well as the water did. However, it does separate them. If you use just water alone, you would just still see the dot. You can try it with water alone. You'll see that it's not going to separate the colors. Cleaning agents are going to be water-based solvents. Now, you can use things like Windex, which would be ammonia-based, or you can use things like vinegar also. Vinegar is going to be is that going to be polar or non-polar? Yeah, vinegar's polar. How do you know? Raise your hand. How do you know that vinegar's polar? Trayvon, how do you know that vinegar's polar? It dissolves in water. Very good. That's the point that I want you to understand. Like dissolves like. So if it dissolves in water, it's going to be polar. Now, vinegar is nice because it is not as polar as water is. So you can see here with the alcohol, you're going to see a similar effect with vinegar. Which one works better? Well, we could have done another experiment to determine that. Which is the better solvent for this particular substance, this particular solute, really, the vinegar or the alcohol. So, I mean, you can do that if you were looking for a science fair project. You can do that as well. It's already known, so you're not really proving anything that's not known. But I don't know, you might be able to change the, I guess you'd say, concentrations to determine which works better. That's how they sell products. Like Windex has a specific concentration that works better to dissolve certain things. That's where they get their information. It's also safe as well. So, polarity, pigment. When we're looking at solvents for cleaning purposes, because that is a mixture. I mean, this is a big business that is in chemistry that is associated with dry cleaners. So cleaning in general is a big chemical business. So a dye, what is a dye? Anybody know? Write this down. A dye is a charged substance. Dyes are charged substances. And pigments tend to be non-charged. So pigments would be like chlorophyll is a pigment. You're out playing soccer or football and you slide and you get chlorophyll all over you. The green pigment, right? Which one's easier to get out of your clothing, a dye or a pigment? Raise your hand. Pigment? Yeah, pigments tend to be easier to get out of your clothing because dyes are going to do what to your clothing? They're going to change the chemical structure. They get in there and actually you're causing, typically a chemical change is associated with a dye. So then what do you have to do if you get a dye in your clothing? You have to add bleach. And what is bleach? Bleach is a dye. So you're basically re-dyeing your clothes when you think about it that way. Most of your dyes come from fruits. Fruits have this ability to produce charged ions, acidic things. And like grapes, wine can be considered a dye when you ferment that. Yeah, if you spill wine on your clothing, you're going to be dyeing your clothing. Much more difficult to get out of your clothing. Sometimes you ruin a shirt if you get a dye on it just because you try to bleach it out. It changes the color of it. Are you familiar with that? You done any cleaning?
Placing 6.5 times 10 to
Cathode ray tubes. The typical cathode ray tube used by researchers for studying the relationship between...
How do you generate electricity? Anybody know? You might know how batteries work? We're going to do a lab on qualitative analysis where you're going to take some aluminum and you're going to put it in copper chloride, and the copper chloride dissolves the aluminum. That's basically how a battery works. There's a paste or a liquid inside the battery, and it will eat up the metal, and when it does that, it releases energy, and you're going to have a little thermometer, and you'll place it in the liquid, and you'll see how the temperature rises. Well, you can capture those electrons if you have a wire in there that's resistant to the corrosion of the solution, and then you can use that for your devices. So that's how batteries work. There's a paste or a liquid that dissolves the metal. Anytime you turn on your tablet, you are basically dissolving the metal inside the battery, the lithium. And when you plug it in, you're making the metal again. You plug it into an outlet, and the electrons basically charge the metal. That is, they put electrons back onto the metal, ion, producing the metal. So metals lose electrons, they become ions. You'll see the chlorine dissolves into water. Correction, the aluminum dissolves into water in the lab we do, and that's an ion. We don't typically have aluminum batteries. It just takes too much electricity to make the aluminum back. So we use things like lithium to do that. Lead, it's just not as effective because its corrosiveness is not as good as lithium is. So lithium is the preferred metal. Now up here on the board, I've got an example of how a motor was discovered. So what does it take to make a motor? What must you have in order to make a motor, Freddie? starts with the M, drives computers. Without this, you can't have a computer. Yeah, magnets. So magnets, when they were found, I mean, magicians would use them. Why are magnets useful to a magician? That makes things move very, very quickly. Magnets are very fast. They can get really quick movements. You can have things stick together like coins that look like they're together, just and the magnet holds them together. You can separate them. Coins, this is when those coin tricks are very common with magnets. Just look them up. So magnets allow things to happen very quickly, movements to happen very fast. So a lot of magicians like them because of this fast movement that a magnet produces. So you have to have a magnet in order to generate electricity, and you have to have a wire. So you see the wires there. They're giving us here in this text a battery, but the motor came first. They had to have a motor to generate electricity. And they have these magnets here, and then you have a spinning, and that's what creates the electricity. So I'm going to play this video. It does a better job of explaining it than I do.
Negative meters. Placing 6.5 times 10 to the 9th copper atom side by side will does result in a line.
Well, with this, so the direct current only has one polarity with the magnet, where you see the north and the south pole. And as the wires spin around, it creates a current directly. Here. So ethanol is polar, it's just weak polar. It has a weaker polarity. So if you ever see ethanol in like a glass bottle, often you'll see it in like alcohol stores, right? And if you look at the bottle and you shake it in its glass, you won't see the water stick or the alcohol sticking to the glass. Compared to if you shake water in a glass bottle, you see the little water droplets sticking to the glass. So ethanol is a lot less sticky compared to water because the distance between the negative and the positive is a lot greater. Everybody see that? Now, how do we know they're both polar? They dissolve in each other. Write this down. There's something called like dissolves like. If you're polar, you dissolve polar things.
I did it. Someone else did. No, that's not.
Okay, send me one now.
No, not yet.
Wait. Go ahead.
This is exactly 91, but it must be 91.
After 2 seconds, stop.
We gotta read the directions. There's a buildup. Set up a ramp using one foot elevated ramp.
That's the reason.
At this time, it says at the top, this time,
The heck?
Please don't.
We're at 13.3.
13.3. Alright, now run it from the top. And you can
40 inches plus. Here we go.
Everything is not going to be where you have to go on its way.
Mr. Soniker, can we film ours?
Put the truck in the front.
Okay, you ready?
Actually,
Ready? Set. Go.
Let's catch up. The police officer, get him.
Yeah.